Have you ever wondered how science could change our lives if we could manipulate materials at the atomic and molecular level? That's the mind-boggling premise of nanoscience and nanotechnology. Let's set the stage. A nanometer is 1/1,000,000th of a meter. To put that in perspective, a single sheet of paper is about 100,000 nanometers thick. When we talk about nanoscience, we're referring to the study of phenomena and manipulation of materials at this incredibly tiny scale, where the properties and behavior of those materials can be very different from what we observe at a larger scale. Nanotechnology, then, is the application of that knowledge to create new materials and devices. It's like being an architect and a builder, but instead of bricks and mortar, you're working with atoms and molecules. You might be surprised to learn that nanotechnology isn't just the stuff of science fiction. It's already a part of our everyday lives. Think about the stain-resistant coating on your favorite shirt or the sunscreen you apply before hitting the beach. These are just two examples of the many ways nanotechnology has snuck into our daily routines. And it's not just about making life more convenient. Nanotechnology has the potential to revolutionize a wide range of sectors, from medicine and energy to electronics and environmental protection. Imagine medical treatments that target individual cells, solar panels as thin and flexible as a sheet of plastic, or ultra-efficient water purification systems. But like any powerful technology, nanotechnology carries both potential benefits and potential risks. It's a double-edged sword. On one side, the promises of a better future; on the other, the perils of unforeseen consequences. As we delve deeper into the nano world, we must navigate this delicate balance with care and thoughtfulness. Stay tuned as we explore the promises, the perils, and the potential of this fascinating field. Imagine a world where diseases like cancer could be treated more effectively, or where clean energy could be produced more efficiently. This isn't just science fiction, it's the potential reality of a future shaped by nanotechnology. At its core, nanotechnology is about manipulating matter on an incredibly small scale. We're talking about the nanometer level here, which is 1/1000,000th of a meter. To put that into perspective, a single strand of human hair is about 80,000 to 100,000 nanometers wide. Now let's delve into the promises of this microscopic world, starting with medicine. Today, most drugs work by flowing through your bloodstream, hoping to bump into the disease they're meant to treat. It's a bit like trying to find a friend in a crowded city without a map. Nanotechnology could change this by designing drugs to target specific cells, like those causing cancer, making treatment more effective and reducing harmful side effects. Moving on to energy production, nanotechnology could revolutionize this field too. Imagine solar panels coated with a nanomaterial that can absorb more sunlight and convert it into electricity more efficiently. Or batteries made with nanotech that can store more energy, charge faster, and last longer. That's the promise of nanotechnology. Cleaner, more efficient energy production. Lastly, let's talk about material science. Nanotechnology could create materials that are lighter, stronger, or even self-healing. Imagine a smartphone screen that can fix its own cracks, or a bridge made from a material 10 times stronger than steel, but half the weight. These are just a few examples of how nanotechnology could impact our lives, from health to energy to the very materials we use every day. Of course, like any technology, it comes with its own set of challenges and potential risks, which we'll explore in the next scene. These are just a few of the ways nanotechnology could transform our world for the better. It's not a question of if, but when and how we'll navigate the promises and potential pitfalls of this exciting field. However, as with any technology, there are potential downsides to nanotechnology that we must consider. As we delve deeper into the realm of nanotechnology, we face a host of potential risks and challenges. Uncharted territory often comes with unforeseen complications, and nanotechnology is no exception. One of the primary concerns lies in the realm of health. The small size of nanoparticles allows them to penetrate biological systems in ways that larger particles cannot. They can cross cell membranes, infiltrate organs, and even breach the blood-brain barrier. While this characteristic can be harnessed for medical benefits, it also poses potential risks. The long-term health effects of exposure to nanoparticles are still largely unknown, and some research suggests that certain nanoparticles may be toxic to human tissue and cells. Moving on, we encounter environmental impacts. The production and disposal of nanoparticles could have significant effects on our environment. Nanoparticles might accumulate in the ecosystem, with unknown effects on plant and animal life. Additionally, the energy-intensive process of producing nanoparticles could contribute to climate change. Then there's the ethical dimension. The incredible capabilities of nanotechnology could widen the gap between the haves and the have-nots. Those with access to nanotechnology could potentially gain significant advantages, deepening societal divisions. Furthermore, the use of nanotechnology in areas like surveillance could raise serious privacy concerns. And let's not forget about the potential for misuse. The same technology that could cure diseases and clean up the environment could also be used to create new kinds of weapons or for other harmful purposes. These challenges underscore the need for regulations to ensure the safe and ethical use of nanotechnology. We must tread carefully, developing guidelines to govern the production, use, and disposal of nanoparticles, and creating safeguards to prevent misuse. These potential risks remind us that while nanotechnology holds great promise, it must be used responsibly. The promise of nanotechnology is immense, but so too are the perils. As we venture further into this exciting field, we must keep our eyes wide open, ready to confront the challenges that lie ahead. So, how do we balance the potential benefits of nanotechnology with its potential risks? This question is at the heart of the debate surrounding nanotechnology. It's not simply about weighing the good against the bad, but rather, it's about understanding how to manage these elements for the betterment of society. Firstly, research is paramount. We need to delve deeper into the workings of nanotechnology, exploring its vast potential while simultaneously uncovering and understanding its risks. This isn't a race to the finish line, but a meticulous journey of discovery. Our scientists need to be the torchbearers in this quest, enlightening us about the intricacies of the nanoworld. Secondly, regulation plays a crucial role. As with any powerful technology, nanotechnology needs oversight to ensure its ethical and safe use. This is where policymakers come in. They need to devise robust frameworks that facilitate innovation while safeguarding against misuse. They should set parameters for research and development, establish standards for commercial use, and create guidelines for ethical considerations. However, science and policy alone cannot dictate the path of nanotechnology. Public dialogue is also essential. The public, being the ultimate beneficiaries or victims of this technology, have a right to be involved in shaping its future. This isn't just about public acceptance, but about public participation. People should be informed about the implications of nanotechnology, and their voices should be heard in discussions about its deployment. In essence, balancing the pros and cons of nanotechnology requires a three-pronged approach: rigorous research, responsible regulation, and robust public dialogue. It's about fostering a culture of collaboration between scientists, policymakers, and the public. It's about acknowledging the potential of nanotechnology, respecting its power, and harnessing it for the collective good. As we move forward, let's remember that the promise of nanotechnology isn't in its power, but in how we wield it. It's not just about what nanotechnology can do, but about what we choose to do with it. It's clear that the future of nanotechnology will depend on how well we can navigate these challenges. What does the future hold for nanotechnology? A question that sparks curiosity, wonder, and a glimpse of the seemingly endless possibilities. The realm of nanotechnology is vast and ever-evolving, promising a future filled with innovation and discovery. As we advance into the coming years, nanotechnology is predicted to reach new heights. Ongoing research is leading us towards incredible advancements in this field. Imagine solar cells as thin as a sheet of paper, yet highly efficient, revolutionizing our approach to sustainable energy. Or nanorobots, smaller than a grain of sand, that could perform precise medical procedures, such as targeted drug delivery, inside our bodies, improving the effectiveness of treatments and minimizing side effects. Furthermore, the evolution of nanotechnology could usher in a new era of environmental restoration. Nanomaterials might be used to clean up oil spills, purify water, and even capture carbon dioxide from the atmosphere, mitigating the effects of climate change. Yet, as we marvel at these potential developments, we must also consider the responsibility that comes with such power. It's crucial that we foster a responsible approach to nanotechnology. This means conducting thorough research to understand the implications, both positive and negative, of these microscopic marvels. It means creating robust regulations to ensure the safe, ethical use of nanotechnology. And it involves educating society about the potential benefits and risks, so that we can make informed decisions about the role of nanotechnology in our lives. In the future, nanotechnology could also play a key role in areas we can't even imagine yet. The possibilities are as countless as the atoms in a nanoparticle. But it's not just about what nanotechnology could do. It's about what we, as a society, choose to do with it. As we look to the future, the possibilities of nanotechnology seem almost limitless. But it's up to us to ensure that this powerful technology is used for the benefit of all.